So now, so these are the some introductory part we see. बर्तमान आमे देखिबा what is drift velocity. So these are the, so initially in a conductor, so there is a random motion, the electrons are in random motion and the net velocity of the electrons becomes 0. That is, this is the random motion of electron, but electrons here move in different direction. You see, they are moving in different directions. But when potential difference applied across the conductor, so here suppose in random motion where 50 electrons, here also 50 electrons. If they move in right, then they move to left. So that net charge will be 0, net flow of charge is equal to 0. Because these electrons are moving left to right and these electrons moving right to left. So that total charge 0. But when potential difference applied, যেতବେଳେ আমি potential difference apply করিবা conductor রে কোন হবো দেখো, and these electrons start moving in one direction. These are the different free electrons within the conductor. দেখো, so these are আমি যদি potential difference connection, that is battery connection করিবা তাহলে, so this is the higher potential, means positive means higher potential and this is the lower potential. Now electrons start moving from lower potential to higher potential. That when these electrons travel, then collide with the other electrons, then they stop there and other electrons move. This process of moving, then when this goes strike, these move, they remain rest. Again these will move, एमाने जिबे ता सहित बाड़ेबे, तब ये जाकि रेस्ट रही जिवो, ये पुणी आगु को पळेबो. एई प्रोसेस ऑफ मोशन टा को एटा कहंती ड्रिफ्ट वेलोसिटी. दिस प्रोसेस ऑफ मोशन इज कॉल्ड ड्रिफ्ट वेलोसिटी. सो इलेक्ट्रॉन इन दिस वे, इन द फाइनल एंड जो इलेक्ट्रॉन थांती, दे विल कम आउट इन द सर्किट एंड फ्लो विद इन द कंडक्टर एवं कंडक्टर भितर फ्लो करंती. So what is the drift velocity of an electron in a conductor? Suppose this it गोटे कंडक्टर आम नहीं, ये गोटे आम बैटरी कनेक्शन कलु, it is higher potential, it is lower potential. Now electrons start moving or drifting from lower potential to higher potential, then and they move with the velocity Vd. Electric field is from positive to negative direction, therefore current will flow along the electric field or opposite to the flow of electrons. In the absence of electric field, at any temperature, the free electrons are randomly moving in all possible directions and the velocities of electrons are called thermal velocity. Therefore, the initial average velocity of the electrons becomes 0, means suppose 50 number of electrons move from left to right, then again 50 number of electrons move from right to left, already we saw. So that net charge will be, net flow of charge will be 0, then current will be 0. So the rate of flow of electrons from left to right at a point is equal to rate from right to left, so that net rate of flow of electron at that point is 0 in the absence of electric field. How do the electrons accelerated in a conductor in the presence of electric field? बर्तमान देखा केमिति इलेक्ट्रॉन गुड़िक कंडक्टर भितर एक्सलरेटेड होती, जितेबाला आम external field apply kariba and drift velocity con. So, an electric field is set off at every point in the conductor when it is connected to a battery. These fields exert a force on the electrons. As they move, they undergo frequent collisions with the atoms or ions of the conductor. Thereby, they acquire a constant speed in a direction opposite to the field. This velocity is called drift velocity, which is of the order of 10 to the power minus 3 meter per second, or 10 to the power minus 3 to 10 to the power minus 4 meter per second. Thus, there is a net flow of charge inside the conductor. So, drift velocity also we can define as the final average velocity of electrons that moved from lower potential to higher potential due to an electric field E. So, while they moving within the conductor, they collide with the other electrons and ions, and so the collisions are inelastic. So, there is a net transfer of energy. So, when they collides with other electrons, the electrons will move forward, but the collide electrons remains rest there. So, the average time interval between two successive collision is called relaxation time, tau. So, because means successive collision, when electron here, suppose this will go and strike here, again this go strike here, this is the collision times, these are called collision times. The average time interval between successive collision is called relaxation time. Then the drift velocity of electron Vd is equal to minus E into E by m into tau. So, E is the electron charge, E is the electric field, m is the mass, and tau is the relaxation time. Hence, the negative sign indicates that the electrons drift opposite to the applied electric field. Now, you see how we derive drift velocity in a conductor. So, we see that in the absence of electric field, the electrons are in random motion. So, in random means suppose if U1, U2, U3 up to Un be their initial average velocities or initial average or sorry initial velocities. So, initial velocities of electrons in the absence of electric field. So, these velocities are called thermal velocities. Then, as the electrons are in random motion, so initial average velocities is equal to 0, or that implies U1 plus U2, U3 up to Un by n is equal to 0. When a potential difference applied across the ends of the conductor. Due to electric field, E, force on each conductor force on each electron F is equal to minus E into E, because here E minus means it is due to electron, it is negative charge, is equal to this much. So then acceleration of the electron is equal to F by m is equal to minus E by m. So due to this acceleration, let V1, V2, V3 up to Vn are the final velocities of these electrons during collision times. During collision times T1, T2, T3 up to Tn respectively, then we have V1 is equal to U1 plus A T1, V2 is equal to U2 plus A T2, V3 is equal to U3 plus A T3 and so on. Taking average of these velocities we have, so average of these velocities average final velocities are V average, and it is also, this is called drift velocity. Average final average velocity gained by the electron is called drift velocity. So the Vt is equal to V1 plus V2 plus V3 up to Vn divided by n, or that implies we now put that is this value, that is U1 plus A T1 plus U2 plus A T2 plus U3 A T3 and up to Un plus A Tn divided by n. So n is the number of collisions, then is equal to U1 plus U2 plus U3 up to Un divided by n plus A, we take commons, it will be T1 plus T2 plus T3 up to Tn by n. But this already I pratham dekhi sarchu, this value is 0. So this is drift velocity is equal plus A and this is tau. This is tau. What is tau? Now tau is the called relaxation time. Relaxation time, or it is the average collision between average time interval between successive collisions. Suppose T1 is the time interval for first collision, T2 is the time interval for second collision, T3 is the time interval for third collision, and these are the average time interval between successive collisions, and it is called relaxation time. Therefore, Vd is equal to A plus tau. Or that implies we see that Vd is equal to A is equal to, we already see that is minus E by M into tau. So, this is the expression of a drift velocity in terms of a electric field. So, we know drift velocity opposite to the applied electric field, that is why it is negative, and magnitude of drift velocity is equal to E tau by M. But we know but E is equal to electric field is equal to V by D, that is potential gradient, or we can write here in place of D it is the L, V by L. Here L is the length of the conductor. Therefore, we can write drift velocity in terms of electric potential E V tau by ml, where V is the potential difference applied across the ends of the conductor. So, this is the expression of a drift velocity. Now, we points to be remembered. When electrons are drifted in a conductor, they will have net average velocity and zero average acceleration. In the absence of external electric field, there will be no current in the conductor. So, now electric current density J. So, what is electric current density? So, electric current density is defined as current flows per unit area, and where area is the normal to the current, and it is, that is I is equal to, J is equal to I by A, current per unit area, where A is the area of a cross section of the conductor. So, the magnitude of current density is the amount of charge flowing per unit cross sectional area per second. It is a vector quantity এবং यार direction along the direction of a current. Current जो दिगरे flow करे सही दिगरे ही current density रो direction. So, if E is the magnitude of uniform electric field in the conductor whose length is L, then potential difference V across it and is E into L is equal to J rho L, where E is equal to J into rho. You see, that is, if E is the magnitude of a electric field in the conductor whose length is L, then potential difference V is equal to E L. Then V is equal to, we can write J rho L, where E is equal to J into rho. How it will be? You see, देखो, तो आम जानिचु from Ohm's law V is equal to I into R. So, I is the current and R is rho L by A, and that implies V is equal to E into L is equal to I by A rho into L. So, when L cancel, that you get E is equal to I by A is current density J and rho. or that implies J is equal to 1 by rho into E, and 1 by rho is called resistivity of the conductor. Rho is called resistivity of the conductor, and 1 by rho is sigma. This is conductivity. So J is equal to sigma into E. So current density is equal to conductivity into electric field. So this is the J is equal to sigma E, where sigma is called conductivity. So SI unit of current density is SI unit of ampere per meter square, and dimensional formula is A L to the power minus 2. And if the conductor is in non-uniform thickness, the current density at different places are different, but current always through the conductor always same. So current सब बेले समान रहिबो, but non-uniform cross section conductor पाई current density will be different at different places. Now आमे देखिबा relation between electric current and drift velocity. So एक केसरे आमे कौन करिबा ना गोटे consider a conductor of a length L and uniform area of a cross section A. Now volume of the conductor is equal to area into length. Area of a cross section into length is the volume of the conductor. And when a battery is connected, kon hobo? Now this is the higher potential, it is the lower potential. Electrons kon karibo drifted with the velocity Vd from lower potential to higher potential. Sei samayre current flows from higher potential to lower potential along the direction of a electric field. Ame janichu electric field direction from positive to negative. So in this way current will flow. Now if N is the charge density, number of free electrons per unit volume of the conductor, if n small n is the number of free electrons per unit volume of the conductor, then total number of free electrons within the conductor will be n is equal to small n A into L. And आमे जानिछु charge of each electron is equal to E. So there are n number of free electrons within the conductor. Therefore total charge within the conductor is equal to n A L into E. So let a constant potential difference V be applied across the ends of the conductor using a battery. Then the electrons will be drifted, and it is drifted from lower potential to higher potential, and the electric field across the conductor will be E is equal to V by L. So due to this field, the electron drifted from lower potential to higher potential, that is right to left. So then time taken by free electrons to cross the conductor, T is equal to distance by velocity, that is length by distance covered is length of the conductor. Therefore आमे लिखि परिबा L by Vd. Hence current I is equal to Q by T. So Q is equal to आमे already देखि सारछु expression Q रो N A L into E, and time is L by Vd. Then L cancel, then it become I is equal to NEA Vd. I is equal to NEA Vd. We already know Vd is equal to E by M into tau. Then we can write current is equal to NA square tau by M into E, and in terms of electric field. So now current density is equal to current per unit area is equal to NEVD. तेणु आम करेन्ट डेनसीटी को ड्रिफ्ट वेलोसिटी फॉर्म रे एक्सप्रेस करी पारिबा. So we see that the relation between current and drift velocity I is equal to NEA VD. बर्तमान आम देखा मोबिलिटी. So mobility of a charge carrier of or electrons in is defined as So, average drift, it is the ratio of average drift velocity to the applied electric field, that is mu or average drift velocity of electrons per unit electric field strength. Mu is equal to drift velocity by electric field. But we know Vd is equal to E tau by m into E. So, E cancel is equal to E tau by m. So, therefore, in a conductor the relaxation time is the same, charge of electron is constant, therefore, mobility is inversely proportional to mass of the charged particle. So, we know ame janichu mass of proton is greater than mass of electron. Therefore, we can write mobility of electron is greater than mobility of proton. The mobility means how freely, meaning actually how freely a charge carrier move within the conductor. Therefore, mu E is equal to mobility of electron and mu P is the mobility of a proton or positive charges. Therefore, in a conductor the mobility of electrons is more than the mobility of positive charges. So, now question MCQ, देखो, what type of collision takes place between electrons and atoms or ions of a conductor? So, that is elastic collision, inelastic collision, semi-inelastic collision, perfectly elastic collision. So, the collision is inelastic collision. The drift velocity of an electron in a copper conductor of cross section 5 into 10 to the power minus 6 meter square is 1.5 into 10 to the power minus 4 meter per second. If current of 10 ampere flows through it, find the number of electrons crossing per unit volume. So, what are the given quantity? So, drift velocity is given 5 into 10 to the power minus 6 meter square, sorry 5. So, drift velocity is, so this is the conductor cross section. So, this is the cross sectional area, A is equal to 5 into 10 to the power minus 6 meter square, and drift velocity is equal to 1.5 into 10 to the power minus 4 meter per second. The current is 10 ampere. Now, we have to calculate what is the number of free electrons per unit volume of the conductor. So, the formula we know, I is equal to NEA Vd. So, here E is the charge of electron, already know 1.6 into minus 10 to the power or 10 to the power minus 19 coulomb. Therefore, we can write N is equal to I by NE A, sorry, I by EA Vd. So, current is equal to 10 ampere divided by 1.6 into 10 to the power minus 19 into area is equal to 5 into 10 to the power minus 6 into 1.5 10 to the power minus 4. It will be 6.25 into 10 to the power 18 into 10 into 10 to the power 10 divided by 5 into 1.5. So, 2. So, nearly it is equal to, and when you cut, so this will be nearly this. So, it will be nearly 8 point or nearly 8.34 into 10 to the power 18, 28. So, nearly that is 8 into 10 to the power 28. So, this is the number of free electrons per. So, the correct option is 8 into 10 to the power 28. So, what is the relation between drift velocity of electrons and electric current? So, drift velocity Vd is equal to I by N AE, Vd is equal to N A I E by I. So, Vd is equal to I by NJE, Vd is equal to JNIE. So, correct option I is equal to this much, Vd is equal to I by NAE. Okay. Thank you.